Good day, everyone. Today we're going to learn and talk about integration of rational functions by parts in fraction. So let's solve and dive to this example, and let's try to make it easier as it looks. So first is we have here a difference of perfect square on our denominator. So we're going to simplify that or factor that out, which gives us the result of 1 over, so the factor of x squared minus 4 is x plus 2 and x minus 2 dx. So we have there on our denominator some linear functions. So the difference between linear and quadratic terms are for the linear, which will represent our L, and for quadratic is our Q. So linear uh, terms are simply just x, 3x, 5x. They have no 2 on the exponent or square on the exponent. Then that differentiates them from the quadratic expressions or terms which has a square on the exponent, x squared plus 2, x squared minus 4, which is our given, and x squared plus 5x plus 7. These are the difference between linear and quadratic terms or equations. So now we have here the factored term for our equation. So let's rewrite this or solve this and divide this equation into two integration parts. So first is we have the integration of our first part, which we're going to call a over x plus 2 dx plus our integration, which is b over x minus 2 dx. So now we have here our two parts. So just to give you a simple gist of what's integration functions by a part is, or integration of by parts of fractions. Let's solve for this. Let's have here 1/4 plus 1/5. So we know that solving fractions that doesn't have the same denominator is we're going to get their LCDs or make their denominators the same. So their denominators or their LCD is 20. So 20 divided by 4 is 5 times 1 is 5. 20 divided by 5 is 4, multiplied by 1 is 4. So it is 9 over 20. So 9 over 20 can also be written as 1 over 5 plus 1 over 20. So these are the two parts of 9 over 20, 1/4 and 1/5. So it is same as here on what we're doing. Now let's move to our next step. So we're going to rewrite this one, our new equation, which is the factored part, and this one. But we're going to first, or we're going to temporarily erase or ignore the integration signs and the x. So let's rewrite it 1 over x plus 2 multiplied by x minus 2 is equal to, cancel again the temporarily the integration signs, a over x plus 2 plus b over x minus 2. And now, to cancel the denominators, we multiplied both sides by x plus 2 and x minus 2. So this will cancel out. So now here we cancel out the denominator on the left hand side of the equation to x plus 2 x minus 2. So now we're left with 1 here is equal to a over x plus 2, and the x plus 2's will cancel out. So we'll be left with a multiplied by x minus 2, which is left, plus b, which is x, cancel out x minus 2, x plus 2. So this is our equation now. So now let's assume, to get the values of our a and b, we need to assume the value of our x. So let's assume it is x is equal to 2. Now a is equal to, or a or 1 is equal to a multiplied by 2 minus 2 is equal to 1 is equal to a multiplied by 0, or simply 0, I mean, plus b multiplied by 2 plus 2 is b is equal to 4. So 1 is equal to b4, multiply both sides or divide both sides by 4 to cancel. B is equal to 1/4. Now let's try for the next one. 1 is equal to x is equal to negative 2. So let's a is equal to negative 2 minus 2 is negative 4, and b is 0. So 1 over r1 a negative 4 negative 4a. So divide both sides by negative 4. So a is equal to negative 4. Now we have the values of a and b. Now we proceed on substituting it on our integration. So we go back to integrating the parts. So we're going back here and we're substituting our values. So we know that our a is negative 1/4. So negative 1/4 over x plus 2 dx, plus b is positive 1/4 over x minus 2 dx. So what we want to do here is we put 1/4 outside the integration. So we are left with 1 here, and here is negative 1/4, and here is positive 1/4 on outside our integration. Now here we can see a pattern for natural log. We know that 1 over x is ln x. 1 over x is equal to ln x. So we can now solve this as a natural log. Like, say for example, we have 1 over x plus 2 is equal to ln absolute value x plus 2. Now we have our constant here 1/4, so we put 1/4 here. So let's solve it. Let's solve it here 1/4, negative 1/4, ln absolute value x plus 2, and here we have 1/4 plus 1/4 absolute value of natural log absolute value of x minus 2 plus c. Now here we can factor out the 1/4. So let's first put the positive 1/4 on the front and have it ln x minus 2 and minus 1/4, I mean minus natural log of x plus 2 plus c. Now we have a property on logarithms that ln a minus ln b is equal to ln a over b, and ln a plus ln b is equal to ln a multiplied by b. Now we have here ln a minus ln b, so we're going to proceed with this property. Now we're going to proceed on the property of ln a minus ln b is equal to ln a over b. So we have here 1/4 our natural log x minus 2, because that's our first on the term, x minus 2 over x plus 2 and plus our constant. So here is our final answer for the antiderivative or integration of 1 over x squared minus 4 dx. And that's how you solve integration by parts using fraction. That's all. Thank you.